Hello, welcome back to another Physical Sciences 3 lecture, and we are looking today at Newton's third law on page 39. And for this one, it is for every force in nature acting from one body to another, there is a force equal in magnitude acting in the opposite direction for the same period of time. Yeah, okay, so I know this better as for every action. Let me make sure I'm drawing. Okay. I know this better as for every action, and when we say action, that's a force, there is an equal and opposite reaction, and that's also a force. So for every force, there is an equal and opposite force. Okay. And we have a couple of diagrams here. So we have two bodies here, A and B. And let's say these were balls and they collided. Then the force from A on B is equal to the force of B on A. And they will accelerate differently, remembering F equals ma. So it may look like one force is experiencing a bigger one object, is experiencing a bigger force than the other, but it just might be that A has a larger mass, and so that means the acceleration that A experiences will be smaller than B, which has a smaller mass but a larger acceleration. Okay. But what they find is that the forces are equal, but they act in the opposite directions, as shown here by the maths here. So the F of A on B, that's what the little subscript stands for, is equal to negative the force of B on A. Okay. These forces are sometimes referred to as Newton's third law action-reaction pairs. So each object experiences one force, each object exerts one force, an action-reaction pair involves two forces. And so if the action is A pushes B, then the reaction is B pushes A. Okay, they're just equal and opposite. Okay, so you will be asked to write down action-reaction pairs like that. Someone on a stationary skateboard jumps forwards off it. What does the skateboard do and why? So the action in this case, I'm just going to write down action, is someone. So person pushes skateboard. And the reaction is skateboard pushes person. Okay, so essentially, if we have a person on a skateboard and they'll be pushing let's say this is F person on skateboard and this is F of skateboard on person. So the person is pushed forwards by the skateboard and the skateboard is pushed backwards by the person. So the person must push the skateboard backwards in order for them to go forwards. Okay. So they're the action-reaction pairs, but that doesn't really. But when they ask a question like this, we need to answer it in kind of like a sentence. So someone on a stationary skateboard, jumps off it. What does the skateboard do and why? So the skateboard will move backwards in opposite direction of person as the force on the skateboard is equal and opposite to the force required to push the person forward. So we'll just say by Newton's third law. Or you can just write N3 or N3. Like that. So, yeah. Okay. So a bee collides with a truck travelling in the opposite direction. Compare the force on the bee and the force on the truck. Okay, so by Newton's third law, by N3, Newton's third law, the force on the bee is equal and opposite the force on the truck. Okay, so they're equal and opposite. So why then does it seem like it's much worse off for the bee compared to the truck? Well, it's because of the masses. Okay, so Newton's second law, by Newton's second law in 2, F net equals ma. So since the bee has a much smaller mass than the truck, the bee experiences a much larger acceleration. Okay, so, and that is why the bee will go splat against the truck. Okie doke. And the acceleration of the bee and the truck, I actually just explained that, didn't I? The acceleration of the bee and the acceleration of the truck. So, and I can just say, we just answered then part A, C, part A. I jumped the gun, didn't I? Alright, I'll leave this one for the next video, the tug of war example.